All right, we are back. Build 2014. Really excellent to have Tarek and Eric here from the C++ team. Now, before this talk, we were talking about .NET Native, and of course, it's your work specifically, Eric, that has enabled that with the backend compilation of IL. So, welcome. So now we're really going native, man.
All right. Thanks.
So, it's been a while since we've talked.
Yes.
What have you been up to? What's going on in terms of conformance? What are some new things that's going on in the C++ world?
Quite a few things, actually, Charles. We've focused, obviously, on conformance. That's a big thing for our customers. We've promised that we're going to keep making C++ 11 and C++ 14 at this point conformance a top priority. We've shipped quite a bit in Visual Studio 2013, and then we followed that late this fall, with a CTP. And Herb yesterday in his talk was also talking about another CTP coming in the next few months. We don't have a specific date for it yet, but it should be coming in soon, where we have even more C++ 11 and C++ 14 features. But I think one of the very interesting things that we're also started working on is compilation speed, and we're trying to kind of make improvements there. And just as a new thing for us is how we're trying to take the cadence of shipping Visual Studio from just shipping, it used to be once every few years. Now then we went into a once every year cadence. Now we have quarterly updates, and then we're trying to add value to customers at a much more rapid cadence. So.
Awesome. So it's interesting. So just quickly to talk about that, in terms of, because you guys build Windows and Xbox and SQL Server and SharePoint and Exchange and X, Y, Z, when you make these quarterly updates, or whatever the number is, and you add new features, that must be quite complex given the fact that adding a new feature could break Windows. How does that work?
Absolutely. So that's a really good question. So what we've been able to do recently is operate at sort of a near ship level day to day. So, right, all of the major C++ projects at Microsoft, we basically compile on a daily or near daily basis. So, Windows is an enormous C++ project. I mean, changes we make to the C++ compiler, we'll know right away if they affect Windows or not. Same thing with SQL, same thing with Office, Azure, you name it. We're using that as a test bed. And what that enables us to do is, with an extremely high confidence, know if something's going to work or not. Right? If we're making some changes, maybe for C++ language conformance, maybe a new optimization, and everything sort of just works after a day, we're pretty confident we can release that publicly, and everything's sort of going to be okay. But we'll, at the same time, we can sort of tailor our work to make sure that the world isn't always in a state of being broken. Right? The Xbox team moves extraordinarily fast, and they're craving the latest compiler updates. They're craving the latest compiler optimizations, not just to build Xbox itself, but to then ship in the XDK. And that cadence sort of, gets us into a groove where we can start shipping software really, really, really quickly. And I'm a huge fan of that.
Awesome.
Actually, one thing that we, probably not a lot of people know is that we've always shipped a compiler at about, every 6 to 8 week cadence. Internally, there are a lot of people inside Microsoft who rely on the Visual C++ compiler, and we've always had a process that we call the LKG process, the last known good process. And basically, we get an LKG compiler out to Windows and to Office and to others roughly every 6 to 8 weeks, and we've always been shipping on that cadence internally. So we always make sure that we have a compiler that is ready and good to go and builds the large battery of internal software that we have. And in addition to that, we also have a number of partners, like top ISVs that we work with, and they provide us with some of their source code that we kind of use it, augment, like Eric said, we kind of build Windows nightly, but we also build some of those third-party code bases on a very regular basis, just to make sure that we're not breaking our external customers as well.
Excellent, man. So, Channel 9 Live is all about you. Thanks for asking questions. Keep them coming. Sean wants to know, is C++ AMP compatible with Windows Phone 8 and Xbox?
It's a good question. So our goal is to make C++ AMP work everywhere on all Microsoft devices. In fact, not only that, we have a goal to eventually take C++ AMP and make sure that it works across multiple platforms, not only those coming from Microsoft. So our long-term goal is to go and say the programming model that you use for Visual C++ and new additions that we add to the language or to libraries, we're actually trying to make available in other places. There are point-in-time issues where a first introduction of something in Windows Phone doesn't have it, so it is not currently working on Windows Phone 8, but it's definitely on our roadmap to make sure that it works on Windows Phone like it is working everywhere else.
Awesome. And I know C++ AMP is Eric's favorite topic, so I mean, what I want to ask is, with the announcement and sort of movement towards DirectX 12, how is that going to impact C++ AMP? That was actually a question that Alesh wasn't able quite to answer up here because it's not his specialty, C++ AMP. But obviously, DirectX is very important to C++ AMP, right? That's what it's built on top of, correct?
Yes.
So the optimizations and stuff that is going on in DirectX 12 will directly impact C++ AMP.
AMP, as you said, builds on top of DirectX. Our team does a bunch of things with DirectX. One of them, obviously, is we base technologies like AMP on DirectX. So yes, as DirectX gets better, AMP does leverage these technologies as well. But another thing that our team does with DirectX is all the DirectX tooling and all the DirectX diagnostics. So those are other things that are going to affect us from a DirectX perspective.
So speaking of which, somebody asked when we had this conversation, I want to debug HLSL.
Yes.
Are you working on that? I mean, I know you've done work around that already, but is that getting better?
We currently have some features that enable a level of debugging for HLSL, and we're adding more.
Right on, man.
Yeah.
All right, so the world's longest question was just up there, but now it's gone. So hey, Zippy, thanks for joining us, man. Wait, good morning. How has the new C++ standard been embraced at Microsoft internally? Any success stories?
Wow, that's a great question. So, as part of our method of shipping compilers often and internally to Microsoft, I mean, we're enabling folks that work on Windows, folks that work on Xbox, folks that work on Office to take advantage of the newest library features, take advantage of the newest C++ features. Do I have any success stories in particular? I can't think of anything off the top of my head, but I can tell you that Lambdas are absolutely everywhere. R-Valley references are absolutely everywhere. They are throughout the Office code base. I know the Office team specifically was dying to get their hands on the latest, on Visual Studio 2013.
Yeah. One thing that happened, I think, also recently at Microsoft is that you started seeing more Microsoft products available on other platforms. And when that happened, it was a good opportunity for a lot of the teams that traditionally have had very stable code bases that have evolved year over year on the Windows platform to go and, for example, go work on iOS or go work on Android. And to be able to do that, you need to significant refactoring the code. So, Office is in that camp, and other teams are also in that camp. And as part of this, there has been a very interesting adoption of more modern C++ usage, especially now that they start using other compilers as well, and now they have the ability to have a wider look at what they can do with their code.
Awesome.
So yes, I think there are some really good success stories inside Microsoft of people using more modern C++, and I think Office is that just looking at where they were and where they are now is definitely one of those, I would say.
Great. I mean, let's be honest. C++ developers like productivity too, right?
Yes.
So, hey, Carlos, and thanks to the great Karsten Januszewski back there for helping make the question nice and compact for us to read. Is the Superscalar processor the best platform to execute .NET, considering that .NET CLR is a stack machine and Superscalar processor is a machine based in registers?
Okay, so I want to start answering that question and finish by answering a different question. So yeah, I mean, I'm a developer, right? I work in optimization space. I sort of really like the idea of reasoning about how your code actually runs on the actual hardware. And when you think about what's going on in .NET and the work that we put in with .NET Native, right? When you're taking C# code, we're making sure this runs natively. Forget the JIT, forget the CLR stuff. We've got the minified CLR. We've got basic assembly instructions that still do what you're expecting out of C# for the most part, but you're going to be running at a native speed. So is a Superscalar processor the right thing for a managed language? Well, for C# compiling it to native, absolutely. Without a doubt, to be able to take advantage of all the stuff that we're used to, all the specific optimizations that are targeted towards Superscalar processors and powerful modern chips, absolutely is the right thing to do. Now, sort of at a higher level, things get a little bit more confusing, but look, we're compiling C# to native code right now. It's assembly code. I think it's the right thing to do. And then, the folks on my team, my colleagues have been working really, really hard at this to not only make it work, but make it be performant. It's a big deal.
Absolutely. And you guys are doing, and you're seeing immediate improvements in startup right off the bat. Because at execution time, the code is already native. So if I have a bunch of IL that gets compiled into something else, the intermediate, whatever, and then the JIT comes and spits out machine code at runtime, that's machine code at runtime. So the code is running at native speed, right? That's the only thing that runs on hardware,
That's
right?
Yep.
So by removing the JIT problem and having an optimized BCL, right, with no reflection, and they've done a bunch of refactoring there and a minified CLR, you're just going to get faster across the board. But the question would be execution speed of code without a JIT should be the same as any native code, correct? Or not correct?
Well, to some extent. I mean, you still have to, the original source code was C#, and right, C# is not a native language, it's a managed language, right? You still got all the garbage collection stuff, you've still got all the runtime checking, you've got exceptions basically up the yin-yang, just anything can throw an exception. And the optimizations that we apply to that, so just for a little bit more feedback, so the team that I work on, we're the C++ compiler optimizer team, but now we're really the native optimizer team. We're using the same compiler optimizations, the same code generation technology, and applying it to C# code, applying it to MSIL as we are to C++. So I got to make sure I stop saying I work on the C++ compiler optimizer, I work on the native optimizer.
Compiler.
Yes, and that's only as of today, am I really allowed to say stuff like that? But right, we still have to maintain the C# isms. Right, we still have to emit runtime checks if you're accessing a vector, for instance. We still have to, deal with all the exceptions stuff of C#. So is it going to be the same performance as native code? If you were to rewrite your stuff in native, well, we're talking different languages, right? Different language semantics, and it's not exactly one-to-one.
It's a great point. I think it needs to be talked about, though.
Okay. Yes. And so sorry, it's a long-winded answer.
It's a great
I'm a
answer.
long-winded kind of
guy. It's a great answer. So let's get to the better questions coming from the geniuses out there. Felix wants to know status of C++ AMP for H sale.
I don't know.
It's fair to say I don't know.
I'm not sure.
Right on.
Yeah.
Carl wants to know C++ 11. When will you fully support it, man? That's what he wants to know. It's a canonical question.
Okay, I want to say that we actually are not looking at C++ 11 only. We're looking at both C++ 11 and C++ 14.
Great.
And our target is that within the coming year, we'll look at us and say that we're largely compliant with C++ 11 and C++ 14.
So this goes back to what we were talking about earlier, right? And it's not an excuse to say, hey, when we add a new feature to a language that compiles Microsoft, we have to make sure that we still compile Microsoft. It's a non-trivial thing. That's not an excuse. But
No.
the moral of the story is it's important to kind of reinforce that you have that, I would say, ball and chain. Because you could just run and implement everything. But guess what? Windows doesn't work anymore. Right, so I just wanted to kind of bring that out because the topic always comes up.
We realize, Charles, that it is very important that as a C++ compiler, you support the full breadth of the language that your customers are going to need. And in a world today where people are creating applications for a number of platforms and they're using different compilers to be able to do that, it is essential that they are able to use the features from C++ and be able to have them work on the different compilers that they have. So I understand somebody's targeting, iOS and they're using Clang, and they're using a certain feature. It'll be very hard for them to come to Visual C++ and not find it, and vice versa. If they're targeting something for Windows and use something with Visual C++, it's very hard for them to go on the other side and not find it. So I think ISO conformance is one way of making that possible.
Right on. So Felix, I don't even think there is a Phoenix anymore, man. But at least not in the real world. So Phoenix was the compiler. Yeah, exactly. So
I used to work on Phoenix.
right on. Hey, it was actually a great idea, man. Right? The Phoenix compiler platform. They use that for Singularity, right?
Yep, that's
They
right.
use that for beep. And so, all right, I like Felix. He likes to ask that kind of stuff. But you've done an incredible amount of really excellent work with optimizing code for modern hardware, which is what your talk was about.
Yes.
So what did Haswell do to your world?
Haswell, in a sense, changed my life. It's right. So the AVX2 architecture and the Haswell microprocessor that was just released in 2013 from Intel, and future processors from AMD will support the same instruction sets. It enables, right? It is the next generation microarchitecture. It is the next generation of instructions that you're going to generate. It's the next generation of performance. That's really what it is. It is, in my opinion, sort of a world-changing technology, the AVX2 instruction set. And I'm really sort of happy that we're able to take advantage of that in the optimizer and in the code generation space. And to say that we're actually, we're now at a point where we're keeping up with modern hardware architectures, and we're keeping up with the performance that's coming in with chips that are released. The Arch SSC2 switch, for instance, SSC2 has been around since 2001, but that is the default hardware architecture when you just do a standard compilation. But at least now we're getting to the point where we can offer optimized for the latest hardware chips.
Right on. And what is it?
The slash arch colon AVX2.
Nice. Yeah. / arch colon AVX2. Yeah. All right. So this is an interesting one. Is there a plan to advance C++, modern C++, for driver development? Now, obviously, maybe he's talking about kernel driver development, which might start a whole can of worms argument. But yeah. Talk to me about that.
That's actually an engagement that we're currently having with the driver developer folks. And right now, people use the WDK to create drivers. And over the past year and a bit now, we've been working with teams working on that to make sure that there's a good Visual Studio experience for the WDK. And there are going to be further improvements that I can't talk about now, but are going to be coming up soon as well as part of the WDK plus Visual Studio story. But that's actually an area where we're looking for continuous feedback as to what can actually be done. So I would definitely love for Girish if they can provide follow-ups in terms of what specifically are they looking for in terms of driver development. And is it more on the kind of language and using modern C++ there, or is it more about the debugging and having kernel mode debugging, or what other stories? There are a number of directions that we can take this, and we're just starting making a better story. So feedback and input is definitely helpful in terms of helping us prioritize what we're doing.
Well, clearly they want auto. They want to be able to use exceptions, right?
Yeah.
They want variadic templates for drivers.
I always like to hear directly from the customer. Yeah. Yes.
So this is a good question, man. What would so .NET Native, does it allow for C++ interop without the CLI stuff? Right. So I wrote I have my .NET Native binaries running, and I want to load or during compile time, I want to load in a C++ DLL. How does that work? How do you interop with C++ from .NET Native?
Good question. I don't know the right. I haven't thought about that.
Yeah, I don't know that the programming model has changed in that. I mean, you could always do a .NET to C++ interop without C++ CLI if you wanted to. I mean, you could just go directly and invoke. C++ CLI, in my opinion, is the best way to interop between C++ and .NET. I don't think .NET Native actually changes that model. It's still, from a programming model perspective, it's still the same.
There's still a virtual machine called the CLR in .NET Native, right?
There is still a .NET runtime.
There is a .NET runtime that's there, and a garbage collector that's managing the heap. And so you'll have to deal with all of the intricacies that you can do, that C++ CLI helps with in terms of your exposition of what you're trying to do.
Ultimately, you need the C++ code to be surfaced as a .NET assembly. And you need to find a way to make that happen, whether you do that as a C# interop layer that uses pinvoke, or whether you use com interop, or whether you use C++ CLI and have that as the shim layer. Yep. You still need some way of translating from C++ to a .NET model type system.
So they have different type systems. Wow. So Heaven's Revenge wants to know how much of the final .NET Native executable is optimized, which is architecture and CPU specific, versus generic code full of heuristics and branches.
That's a good question.
So I can give some feedback here. We just did a demo of automatic vectorization targeting 128-bit SSC2 code of C#. Making the N-body demo run really, really fast as sort of as a technology demonstrator that we can do architecture-specific stuff as part of the C# compilation process. And this comes back to what I mentioned before. We're going to be able to take advantage of all of the native compilation, native optimization, native code generation things that we do and apply them to .NET Native. So it will be coming. Hardware-specific stuff will be coming. I would love to be able to compile my C# code with /arch AVX2.
Nice. That would be very, very cool.
That would be really cool.
So we're going to speed up a little bit faster now because unfortunately we have about 9 minutes left. This time goes by way too fast. So in later C++ standard, we will see some kind of reflection API. People like reflection for obvious reasons. Why not have some similarity, think, for Roslyn for C++? So there are two different questions. One is Roslyn for C++ could be interesting, and whatever the other one was, I'm sorry.
Yeah, so we, in terms of Roslyn for C++, Roslyn provides a number of things in addition to now being open source, which is amazing. One of the things that it really provides is the ability to provide deep static analysis on C++ and on C# and inference on the code. And I think static analysis on C++ is something that we are working on. In terms of actually creating a public API for that, I think we're not there yet. Is it something that we would like to do and have one day? Yes. It's just not what we're focused on at this point. We're definitely focused on having better static analysis that we can use ourselves. And we're also focused on making sure that we get compilation speeds significantly better. And that's, I think these are kind of our priorities at this point.
Cool. Rajib wants to know, is there any plan to implement template export in MSVC?
So I'll take this and bucket it actually with the next question that I see here, which is about C++ 14 support, and kind of group them together. So the way that we're looking at standards conformance is now, I think with the latest standards meeting, we know exactly what the shape of C++ 14 is going to look like when it gets ratified. So now we understand the full closure of C++ 11 features, C++ 14 features, and what needs to be done. We've already looked at those lists, and we've prioritized them, and we put them on our blog. And this is where we're saying, here's the feature that we're going to do when. So we're actually started implementing some C++ 14 features. And some of them already shipped in Visual Studio 2013, and some of them shipped in the CTP that we just released in November. Cool. And we're going to continue having full C++ 11 and C++ 14 conformance. And as I mentioned in earlier question, I expect that to take the better part of a coming year. But as to specific features, I think on our blog we specifically stated which features we're going to do first and which features we're going to leave for later. Right on. So, and we definitely love feedback there on, I think it's a healthy discussion to have on the blog in terms of people helping us, like, oh, actually, you know what, that one specific thing that you're putting near the end, there are a number of people that would prioritize it differently. That's a healthy discussion to have.
Maybe there should be something like the Reddit style of voting things up, like dynamically on a web page, on the blog. Have people vote for features, and you know what I mean?
That would be awesome.
All right, so this is for you, obviously, Eric. Felix says, Haswell has transactional synchronization extensions. Any plan to utilize them?
Yes. So Haswell's got a lot of stuff. Yeah, here's me being long-winded. So Haswell's got a lot of stuff. It's an amazing set of features that are in AVX2. We've got fuse, multiply, accumulate. We've got gather support. We've got broadcast support. We've got, in the Haswell chip, they've doubled the bandwidth of the L2 cache. Apologize for geeking out for those at home who don't know what I'm talking about. Just bear with me. Memory goes a lot faster when you double the bandwidth of an L2 cache. There's the lock HLE. There's hardware, there's the lock elision work, and then there's the transactional memory support as well. There's also bit masking, the bit manipulation instructions. Wow. These are just an enormous set of features that are in this instruction set, and we want, as best as possible, to do as much as we can, target all of that. Right, and with the initial release of the Haswell support at the /arch AVX2 switch, we are part of the way there. We haven't done the HLE or the STM or the VMI stuff, three-letter acronyms, but we've done the fuse, multiply, accumulate support, we've done gather, we've done broadcast. So it's just time before we start integrating the rest of it.
Interesting. It's interesting to hear about the transactional memory support.
It's really cool.
Right on, man. So, of course, MFC. Our old friend.
Yes.
So are there any plans for any improvements in the future?
So the way we're looking at MFC is that at this point in time, we're making sure that we have service and support for MFC and continue to include it in the product. I don't think people should expect that we're going to have significant. We currently have no plans for significant additions to MFC the way we did, for example, in 2008 and went and added Big Ribbon APIs and others. So we're going to keep MFC in the. We're going to support the code that you currently have. We're going to make sure that it continues to run on the environments that we support in Visual Studio. But what I hope to see is that instead of breathing in life in MFC, actually have a modern desktop UI framework that people can actually use, and then that would actually have the things that people want in terms of decent designers, in terms of hardware acceleration, in terms of interoperability with other new technologies that are coming up, and having very seamless integration with DirectX and other things that we know people want to do. So I think that's where I hope the world goes. I have nothing to talk about at this point in terms of any new UI framework, but I think that's the direction that we want to go, as opposed to kind of keep putting some funding in MFC. It's not going to go away, so if you have MFC applications, by all means, it's a very good way to develop for the Windows platform and continue to maintain applications for the Windows platform. But I don't know that that's going to be our future going forward.
Okay, so now we're going to play the 4-minute Let's Go Quick game, so because we want to get through these questions. So this guy wants to know, what's the Windows version of libdispatch, so Grand Central Dispatch in the Mac? Do we know? Don't know. Anyone know?
Sorry, no.
So Heaven's Revenge again. With all the best bits coming from C++ compiler, would it be fun to replace the current JavaScript engine with Ryujit to see how it behaves?
It sounds like fun. I don't know what Ryujit is.
So Ryujit is the new high-performance JIT for .NET that they've worked on. It's actually lighter weight, super fast, parallelized, takes advantage of multi-core, takes advantage of SIMD. You can do SIMD instructions and stuff. It's the latest generation of the JIT.
Sounds like a fun project. I don't know.
Let's see. We'd like to hear about the ARM optimization as Windows on ARM becomes more relevant. ARM.
Yep. So I'm not an expert by any means on what we do for ARM optimizations, but we absolutely do them. We know past versions of the compiler have been behind other compilers in terms of optimizations on ARM, and we're absolutely doing what we can for that, not just for ARM, but for the Neon instruction set for future ARM chips. Absolutely, we're working on it.
In fact, for update 2, I think we have some pretty interesting improvements in ARM code generation speeds. So
when is
we
ARM
went
V8?
significantly better on CoreMark as well. So.
Is ARM V8 ever going to ship? Like, when's the next version of ARM coming? We don't know. They had some really interesting features that I saw.
We continue to work on all the new chips that are coming up, and rest assured that when a certain chip is important for the Microsoft platform, we're going to be there.
Right on. How about C99 support? Wow, that took a long time.
Yeah.
C99, man, it's 2014.
So so there's C11 now. So I think there are two ways that we look at C11 support, or C99 being part of C11. What we are saying is there's parts of C11 that are a subset of C++11. So obviously those we're doing as part of our C++11 support. There are parts of C11 that are not parts of C++11. And in the past, our message was, C, yes, we are a great C++ compiler, but we don't do a lot with C, and we kind of put it as lower priority. In the last release, we focused on some specific sets of libraries, and we wanted to bring those libraries forward and make sure that they work great with Visual Studio. So one such library that we focused on was FFmpeg, and we made sure that whatever C99 features at the time that it needed, that we implemented in our compiler. I think we're kind of taking a similar approach to C compatibility, which is there are specific libraries out there in the open source that we care about making sure that they work. And for those, if there are needed C11 features or C99 features, we're going to implement them. But we don't have a plan like we have for C++11 or in C++14 to, by a certain date, make sure that we're done with all the features.
Interesting.
We're treating it as a, make sure that our customers who need open source libraries that rely on C have them.
Excellent. Great. I mean, C, it happens to be a widely used language. There's a guy over here, I think, who uses a little bit of it. So,
every day.
Let's see. Will Microsoft consider no? Well, why not ask you this? We announced yesterday that we open source C# and VB. We called it Project Roslyn. Are you going to open source the back-end, front-end C++ compilers?
You know, I don't want to make a joke right now, but I'll go ahead and make it anyways. I really don't want someone to be looking at my code just quite yet. There are a very, very, very interesting set of challenges when it comes to the C++ compiler, just the history involved. And I'm not going to be able to answer that question aside from sort of brushing it aside with some kind of light humor. Unfortunately, Tarek, if you've got something more to say.
I'm going to say that we currently don't have plans to do that.
Yeah.
If it makes sense one day, maybe we'll do it. I'll never say never. But,
so somebody said start a user voice for features.
there you go.
Great call, and hey, always great to see you guys. Unfortunately, the time has run out, and people have to watch a build session now, man. What's going on here? Right on. Enjoy. It's going to be great.
Thank you, Charles.
Great to see you again.
Good to see you.
All right, thanks, Charles.
Thanks, man.